Hello, students. Today we're going to go over the 1.5 and 1.6 notes together. As a normal, we'll start with vocabulary. The vocabulary we have to begin with is verbal model. A verbal model is just an equation written in words. So basically, it's a sentence describing an equation. Okay? And then you would write the equation from those words. This has a lot to do with word problems, so we're going to look at some of those. The first example here says the driving distance between Boston, Massachusetts and Cleveland, Ohio is about 660 miles. If you drive this trip in a total of 12 and a half hours, what is your average speed? So the important information is the distance between the two places is 660 miles. It says you're driving a total of 12 and a half hours and it wants to know your speed. From this information, I gather that we're going to need to use the formula for distance. Okay, so distance equals rate times time. They told us the distance, that's the 660 miles. They also told us the time. We're going to be finding the average speed, which is the rate. So I'm going to substitute. 660 goes in the place of distance. We don't know the rate, but we do know that the time is 12.5. Okay, so I could rewrite this as 12.5 times r equals 660 and solve for the rate. To solve, I divide both sides by 12.5. And I get r equal to 52.8 miles per hour. And I know it's miles per hour because we went a distance in miles, that was our units, and the units for time was hours, so it's miles per hour. Let's go ahead and look at example 2. The table shows the number of seats in each of the first 4 rows of an auditorium. The remaining 10 rows follow the same pattern. Find the number of seats in the last 2 rows of the auditorium. So, this table is showing us that row 1 has 12 seats, row 2 has 14 seats, row 3 has 16 seats, row 4 has 18 seats. So we want to write an equation first to use, and that's how we will find the number of seats in the last row. Let's find a pattern. If you notice, each row goes up by 1, the number of seats go up by 2. So with each additional row, there's 2 more seats in that row. We're going to write a formula in the pattern of a linear equation. So we're going to think of it as a y equals mx plus b type equation. So recall that in this formula, the b is our y-intercept, or where x equals 0. Our rows are the x, our seats are the y. So we could find, if there were theoretically a row 0, we could find how many seats or our y value there by using the pattern of going back by 2. So if I do that, if there was a row 0, there would be 10 seats. That means that our b is 10. Now with each row we increase by 2. That's our slope, or our m. It increases by 2 each time. So the number of seats, let's use s, equals 2 times the row plus 10. Okay. So there's 10 more rows after these first 4, because it says the remaining 10 rows follow the same pattern. This tells me if there's already 4 rows and then there's 10 more on top of that, we have a total of 14 rows. So to find out how many seats are in that row, I will substitute r with 14. So I get 28 plus 10, which means that that 14th row has 38 seats. And we're done. Let's go ahead and look at the next word problem. In example 3, it says your long distance telephone plan charges 8 cents per minute for weekday daytime calls and 5 cents per minute for night and weekend calls. If you made a total of 220 minutes of long distance calls during one billing cycle and your bill was $13.16, not including taxes and fees, how many minutes of night and weekend calls did you make? So let's pull the important information out here. Your long distance telephone plan charges, it's 8 cents per minute for weekday. It's 5 cents per minute for night and weekend. You made a total of 220 minutes of long distance calls, and your total bill is $13.16. So we know that our total that we paid, or our equation, should be equal to $13.16. Daytime minutes are 8 cents each. So we know it's going to be 0.08, 8 cents, times the number of daytime minutes. Okay, so however many minutes you called during the day is going to be D. Now, we are also adding how many long distance minutes we used for nighttime and weekends. So it says 5 cents per night. So we know we're going to be multiplying times 0.05. But then we have to think about what we're multiplying that by. Okay? Because it doesn't tell us how many nighttime minutes we used. But we do know if we used a total of 220 minutes and we subtract the number of daytime minutes, that should equal the nighttime minutes. So just to recap, daytime minutes times 8 cents plus 5 cents for nighttime minutes times, we took the 220 total minutes we used, subtracted the daytime, that gives us how many nighttime minutes there are, and the total cost should equal $13.16. So now we simplify. 0.08D plus, we distribute that 0.05, so it becomes 11 minus 0.05D equals $13.16. 0.08D minus 0.05D equals 0.03D plus 11 equals $13.16. We subtract the 11. 0.03D equals $2.16, and then we divide by 0.03. So I get that daytime minutes is 72. So that's daytime. Now it asks how many minutes of the night and weekend calls did you make? So then to find that, it's 220 minus 72. So 148 minutes. And we're done. So next on the notes, we're going to go over linear inequalities. A linear inequality is an inequality with an equation of a line. So recall, an inequality has what you would know as alligator mouse from your younger years of school, which look like this. So it's essentially like an equation of a line, but instead of an equal sign, it has one of these symbols. So we're going to take a look at these and how to graph them on a number line today. We're also going to go over solving some of them. So let's begin with the basics of graphing them. In example 1, part A, it says graph x is greater than -3. When you're graphing these in a number line, it's important to know that if there's no line underneath your arrow, it's an open dot at that number. If there is a line, if it's an or equal to inequality, you would color in the dot. So for this first one, there's no line underneath, so it's going to be an open dot at -3. This says x is bigger than negative 3. So that means we're going to color in all the values that are larger than negative 3. And we're done. For the next one, x is less than or equal to 0. Since it's or equal to, we're going to color in our dot at 0. And it's less than, so we shade to the left. Now there are compound inequalities that we will need to graph as well. In part A of example 2, this is known as an AND compound inequality. Part B is an OR. And we do graph them different ways. So for the AND, you're going to be shading towards the numbers in between them. So here, first we have the x value is related to negative 2, and it's greater than or equal to. So that means I put a colored in dot at negative 2. For the other one, it's an open dot at 3. And we have a sandwich here. Notice the x is sandwiched between the two numbers, so we make a sandwich with our dots. So our values for x are between 3 and negative 2. When it's OR, there's no sandwich here. They're not stuck together, okay? So we're just going to graph each one individually. X is less than negative 1, means there's an open dot at negative 1, and we shade to the left. Or, for the next part, x is greater than or equal to net 1. So since it's greater than or equal to, we put a closed dot, and then we shade to the right. So notice the shading goes away from each other in the OR problems, towards each other in the AND. Now let's go over some solving and graphing. So first, to solve this compound inequality, I'm going to write it again, just to make it a little bit easier to solve. In these problems, you're trying to get that x alone in the middle. If it helps you to draw these lines, you can, but it is not required. So whatever you do to the middle, you also have to do to the left and the right. To get x alone, I'm going to start by subtracting 5 in the middle, the right, and the left. I get negative 15 is less than 3x. It's less than or equal to 3. Now I divide everything by 3. So I get negative 5 less than x less than or equal to 1. And since x is now alone, we're done with the solving. Next, we need to graph it on the number line. I'm going to have an open dot at negative 5, a closed dot at 1. Since this is an AND problem, I know I shade in between. And I'm done. For the next one, we have an OR problem. So for these OR ones, you just solve each inequality separately, and then we'll put them back together at the end. So I'm going to write each of these inequalities. I'm going to solve the left one first. I'm going to add 1 to each side. I get 2x is less than or equal to negative 6, and then I'm going to divide by 2. X is less than or equal to negative 3. Now I'm going to solve the next one. I'm going to subtract 3 from each side. 4x is greater than or equal to 4. Divide by 4. X is greater than or equal to 1. Now the important thing is to remember at the end for your answer, you put OR between your two problems. So our answer is x is less than or equal to negative 3, or x is greater than or equal to 1. Now to graph this, I put a closed dot at negative 3. Shade to the left, close dot at 1, shade to the right, and we're done. And that's it for our notes today. If you have any questions, go ahead and contact your teacher.